What if we could build human tissue like a 3D printer builds objects, using living cells and natural materials? That's the idea behind 3D bioprinting, a cutting-edge technology that organizes cells into structures, mimicking the architecture and behavior of real tissue. It's not just about printing a shape, it's about recreating the intricate complexity of living tissue. While fully printing organs remains a challenge, bioprinting shows promise for treating tubular organs, like the esophagus, bladder and urethra. The Strong UR project is addressing one of these challenges, urethral stricture, a narrowing of the male urethra that can cause serious complications, such as urinary retention and bladder damage. Current treatments are effective, but complicated by the urethra's delicate anatomy and lack of suitable replacement tissues, leading to long-term disability and high costs. Strong UR brings together scientists, clinicians and engineers across Europe to develop a regenerative solution that helps the body grow healthy urethral tissue.
What makes our project unique is the fact that we are, first of all, doing a comprehensive study on the structure of the human urethra to understand the structure and function relationship. Based on this information, we are going to develop these bioprinting strategies where we are personalizing the architecture and the composition of the tissue structures, and afterwards we are going to validate these models.
The team is developing advanced bioinks, living cells combined with hydrogels that replicate the mechanical and biological properties of natural urethral tissue. Once printed, these bioinks form patient-specific tissue structures. 2 surgical strategies are being explored. One uses a portable biopen that allows surgeons to print bioinks directly into the body during surgery in a single procedure. The second, more complex, involves a multi-step process to create grafts with a modular bioprinting platform for full or partial urethral reconstruction. These regenerative solutions offer a promising new approach in treating urethral strictures and can significantly improve patients' quality of life. Strong UR's relevance goes beyond one medical condition. It's helping make 3D bioprinted regeneration of all tubular organs a reality, accelerating a new era of personalized regenerative healthcare that addresses currently unmet medical needs.